My name is Max and I am the AI avatar of Rymax Lubricants. I am created to give technical trainings in the Rymax Academy, so it is my goal to become your trusted teacher when it comes to lubricants knowledge. Of course, you can still always reach out to the real people at the head office of Rymax, and don't worry, I will not feel offended. This training video is about lubricants for the heavy-duty segment. Heavy-duty applications come in many different forms. You can think of road transport trucks for the logistical sector, big and small, but also off-road trucks, for example in the forestry industry, or in construction. But there are also many different lubricants required in machines like bulldozers, dump trucks, excavators, or cement trucks. And don't forget, industrial applications, in for example factories. These applications can easily be put in the heavy-duty category because of the high demands in terms of continuity, durability, performance, and cost-effectiveness. This kind of equipment and machines require different products for the engines, gearbox, drivetrain, brakes, hydraulic systems, and so on. And we also need to consider age, make, and environment where the equipment operates. All the different products have their own specifications and requirements. To understand more about this, Rymax Lubricants has created this training program. Through different chapters, we guide you through the most important facts of heavy-duty lubrication. We will kick off with the most relevant question: why is a lubricant needed in a combustion engine? But before we start, let me show you the different topics we will discuss. Every day, many kinds of different vehicles travel vast distances, carrying goods, people, or loads from one place to another, powering economies and connecting communities. But what keeps these important vehicles and machines running smoothly? Enter the world of lubricants, the unmissable operational and maintenance products for all vehicles and machines. Lubricants play a vital role in reducing friction between moving parts. This kind of friction is present in every kind of combustion engine, which can be described as an engine that uses petrol, diesel, LPG, or a hybrid technique to generate power. We will zoom in further on the concept of combustion engines in another chapter. But in every case, lubricants are essential to help dissipate heat, preventing overheating, and ensuring optimal engine performance. But it's not just about reducing friction and heat. Lubricants also protect metal surfaces from corrosion. In the face of heavy conditions and challenging working conditions for this kind of equipment, lubricants act as a shield, preventing moisture and other corrosive elements from damaging engine components. Furthermore, lubricants seal the gaps between moving parts, keeping out harmful contaminants that could otherwise compromise engine efficiency, for example in the form of greases. By ensuring smooth operation, dissipating heat, preventing corrosion, and sealing critical components, lubricants extend the life of trucks, keeping them on the road for longer, and ensuring goods, people, and loads reach their destinations safely and efficiently. Vehicles that are powered by combustion engines simply cannot do without good quality lubrication. Ever wondered what drives those big trucks down the road? It's all about the process called combustion. Let's dive into it in simple terms, especially in the context of truck engines. First, just like in your car, fuel, typically diesel or petrol, mixes with air inside the engine's combustion chamber, or cylinder. This is done by a device called the carburetor. Then comes the spark from the spark plug, or in the case of diesel engines which power almost all heavy-duty machines, self-generated heat from the compression, igniting the mixture. Once ignited, the fuel-air mixture burns fiercely in the cylinder, releasing tremendous heat and energy. This creates high pressure that drives the piston down. The downward motion of the piston turns the crankshaft, which is like the engine's powerhouse, converting the energy into rotational motion. This powerful rotational motion drives the truck's wheels, propelling it forward. After all the action, the exhaust gases, including carbon dioxide and nitrogen oxides, are expelled through the exhaust system. In some cases, depending on your engine, these exhaust gases are used to drive a turbo system, making the combustion and power generation even more efficient. So, it's the process of combustion, where fuel and air are ignited in the engine's cylinders that generate power to drive a car, truck, or any fuel-powered machine forward. Imagine all the metal parts in this mechanical process that must endure these ongoing immense forces. This should give you already some idea of the importance of good lubrication. When it comes to engine oil, not all vehicles are created equal. Let's explore the key differences between car engine oil and truck engine oil. At first glance, they might seem similar, but look closer, and you'll see the distinctions that make each tailored to its specific application. Truck engines endure heavier loads and higher stress levels than cars. Not only are they developed to carry heavy loads, but they are also designed to be operational as much as possible. A heavy-duty machine is too expensive to be idle on a parking lot. It's the most economical when it's working, so operators try to use their machines 24/7. Imagine the stress that is put on the mechanical part of such machines. Therefore, truck engine oil is formulated with higher viscosity grades and enhanced load-bearing additives to withstand the increased stress, pressure, and friction. Truck engine oils have superior detergency and dispersancy properties to combat the accumulation of contaminants and deposits over extended drain intervals, ensuring engine cleanliness and longevity. We will also look further into this in another chapter of this training. Truck engines operate at higher temperatures for longer periods, necessitating truck engine oils with robust oxidation inhibitors to resist thermal breakdown and maintain oil stability under severe conditions. Truck engine oils contain specialized additive packages, including higher levels of anti-wear agents and corrosion inhibitors, to provide enhanced protection and performance in heavy-duty applications. Truck engine oils may incorporate friction-modifying additives or low-viscosity formulations to optimize fuel economy without compromising engine protection, addressing the very important efficiency needs of the fuel used by commercial trucking fleets. Truck engine oils are formulated to be compatible with sophisticated emission control systems found in modern diesel engines, minimizing the risk of component failure or catalyst poisoning caused by oil-derived contaminants, but also to meet the stringent emission demands, for example, Euro 6. Meeting these demands is essential for everyone running heavy-duty equipment in a commercial way. Using the right lubricants will help meet these demands. In the world of engine oils, each vehicle type has its own unique demands. Whether it's hauling heavy loads or cruising down the highway in very hot or very cold conditions, using good or poor quality fuels, choosing the right oil ensures optimal performance and longevity for your vehicle. When we look at gears and gearboxes in heavy-duty applications, it is important to understand what they do, how it works, and why it is important to lubricate. Next to the important basic understanding of gear lubrication, we will also teach you about the specifications you need to consider when choosing any gear oil. Now let's see what keeps heavy-duty trucks running smoothly. One of the answers is gear oil and API gear classifications. Gear oil acts as the lifeblood of your truck's transmission, protecting gears and bearings from wear and tear. It reduces friction between moving parts, preventing heat buildup and premature component failure. Gear oil also contains anti-rust and corrosion additives, safeguarding components even in harsh environments to ensure that the equipment can stay operational as long as possible. At high speeds, gear oil creates a cushion of fluid between the gears, completely separating the metal surfaces. At lower speeds, or under heavy loads, special additives in the oil provide extra protection to keep the gears from wearing out. These additives include extreme pressure, EP additives, which protect the gears under high pressure, anti-foaming agents that keep the oil from foaming up, and oxidation inhibitors that keep the oil from breaking down over time. Choosing the right gear oil depends on several factors, including your specific application and climate. Here's where API service classifications come in. The American Petroleum Institute, or API, classifies gear oils based on their viscosity and performance characteristics. Common classifications include API GL4, suitable for manual transmissions and gearboxes in moderate-duty applications. API GL5, designed for heavy-duty transmissions and differentials handling high loads and pressures. Synthetic gear oils offer superior performance in extreme temperatures, improved fuel efficiency, and extended drain intervals. Important to say is that you should always consult your truck manufacturer's recommendations to ensure you're using the appropriate API classification for optimal performance and protection. By understanding gear oil and API service classifications, you can make the right decisions about lubricant selection for your heavy-duty trucks and equipment. Ever wondered why brake fluid could be important in trucks? Well, let's put the brakes on and find out. In trucks, you generally will see two types of brake systems: air brakes or hydraulic brakes. The air brakes will make the typical hissing sound when putting to a full stop. For this training, we will focus only on the hydraulic brake systems because they rely on brake fluid to transfer force from the brake pedal to the brake calipers or wheel cylinders. When you hit the brakes, kinetic energy turns into heat. Brake fluid steps in to absorb and dissipate this heat, keeping the brake system from overheating. This is essential because it prevents the heat to form air bubbles in the brake system and thereby reducing its function. And that's not all. Brake fluid also acts as a corrosion inhibitor, protecting brake components from rust and corrosion, crucial for heavy-duty trucks operating in diverse conditions. And it's not just about stopping power. Brake fluid also keeps seals lubricated and flexible, preventing leaks and maintaining hydraulic pressure. Plus, brake fluid has a high boiling point, vital for trucks facing intense braking conditions like downhill descents or heavy loads. This prevents brake fluid from vaporizing under high temperatures, ensuring consistent braking performance. But what exactly is the go-to brake fluid for these heavy-duty machines? Let me explain. Brake fluid, the lifeline of hydraulic brake systems, found in trucks and vehicles alike. DOT stands for Department of Transportation, which is the organization that categorizes the different fluids. DOT3 brake fluid, commonly used in trucks, is glycol-based and suitable for everyday driving conditions. Stepping up the game is DOT4 brake fluid, also glycol-based, but with a higher boiling point, making it ideal for heavy-duty trucks facing heavier braking demands. Then there's DOT5, a silicone-based fluid known for its high boiling point and compatibility with certain materials, although less common in heavy-duty trucks. Finally, DOT5.1 brake fluid, also glycol-based, boasts an even higher boiling point than DOT4, offering top-notch performance under extreme temperatures, for example in racing. Among these options, DOT3 and DOT4 are the most commonly used in the world of heavy-duty trucks. So, the next time you see a truck cruising down the road, remember, its reliable braking power is thanks to the carefully chosen brake fluid running through its veins. In heavy-duty trucks and machines, the engine works hard, generating a significant amount of heat. Coolants are essential to managing this heat and maintaining the engine's optimal operating temperature and performance. The engine cooling system circulates coolant through the engine block and cylinder head, absorbing heat generated by the combustion process and transferring it to the radiator. Once at the radiator, the coolant is cooled down by airflow and releases heat to the surrounding air, cooling it down before returning to the engine to repeat the process. Here are some key reasons why coolants are essential for heavy-duty trucks. Heat dissipation. Coolants absorb heat from the engine, preventing it from overheating and causing damage to components. Corrosion protection. Coolants contain corrosion inhibitors that protect the engine's metal components from rust and corrosion, prolonging their lifespan. Freeze protection. In cold climates, coolants prevent the engine's cooling system from freezing, ensuring it remains operational even in sub-zero temperatures. Boil-over prevention. Coolants raise the boiling point of the engine's cooling system, reducing the risk of boil-over during high-temperature operation. Lubrication. Some coolants also provide lubrication for the water pump and other components of the cooling system, reducing wear and extending their lifespan. So, next time you see a big truck on the road, just remember, there's a little coolant working hard behind the scenes to keep that engine running cool and smooth. Let's talk about the roles of greases. Greases are critical for reducing friction, preventing wear, protecting against corrosion, and sealing out contaminants. These functions are vital to ensure the longevity and efficiency of both trucks and industrial equipments. In trucks, grease is commonly used in several key areas. For instance, wheel bearings. Grease here reduces friction and wear, ensuring the bearings spin smoothly and last longer. The chassis has multiple points requiring grease, such as suspension joints, steering linkages, and universal joints. Grease maintains flexibility and minimizes wear in these components. The fifth wheel, which is the coupling between the truck and trailer, also needs grease to pivot smoothly and avoid metal-to-metal contact. Brake components, including slack adjusters and camshafts, need grease to operate effectively and safely. Drive shafts, particularly universal joints and slip joints, require grease to handle the high rotational forces and the various angles they operate at. Bearings in motors, pumps, and conveyor systems need grease to reduce friction and prolong their operational life. Gears, whether open or closed, rely on grease to prevent wear and reduce friction. Lastly, bushings and pins in heavy machinery, like excavators and loaders, need grease to handle heavy loads and pivoting actions. Choosing the right type of grease is crucial. Here are some common types used in these applications. Lithium grease is versatile and widely used. It offers good water resistance and stability, making it ideal for automotive and industrial use. Calcium grease is excellent for water resistance and is often used in marine and wet environments, or in dirty environments found in industrial locations. Polyurea grease is suitable for high-temperature applications and is commonly used in electric motor bearings. Molybdenum disulfide, or moly grease, contains solid lubricants for extreme pressure applications. It's frequently used in heavy-duty equipment. Synthetic grease, made from synthetic oils, performs well in extreme temperatures and is used in demanding industrial applications. Aluminum complex grease provides excellent water resistance and stability, making it suitable for high-temperature automotive and industrial applications. When selecting a grease, consider the load, temperature, environment, and speed of the application. Proper greasing ensures the longevity and optimal performance of your trucks and industrial equipments, reducing downtime and high maintenance costs. Let us have a look at the Rymax products. We took the Endurox LD 15W40 as an example. You will find quite a lot of information on the labels of this product. We will discuss the main key characteristics of this product to make you better understand the difference between this product and another product. First of all, view the number written big and bold, 15W40. 15W40 is the viscosity of the product. But what does this mean? The viscosity of the product? The viscosity is a measurement of resistance to flow at one temperature. As example, water has a very low viscosity, and honey has a high viscosity. The same goes for oil. Some oils are rather thin, and some oils are thicker. The lower the numbers, the lower the viscosity. So a viscosity of 10 is lower than a viscosity of 50, which means the viscosity of 10 is thinner. For engine oils, the viscosity is classified by the Society of Automotive Engineers, SAE. Therefore, you see often SAE written in front of the viscosity numbers, like SAE 50 or SAE 5W40. SAE makes a difference between monograde and multigrade oil grades. Monograde oil can be recognized by the fact that there is only one number, like SAE 50. Multigrade oils can easily be recognized by the two values on either side of the W in the viscosity classification, like ACEA 5W40. The W stands for winter. The number on the left side of the W in the viscosity classification informs you about the winter or cold property characteristics of this product, which means it indicates how well the product flows when the engine is cold and not at operating temperature yet. The number on the right side of the W informs you about the summer property characteristics of this product, which means it indicates how well the product flows under hot circumstances when the engine is at operating temperature. The bigger the gap between the value before the W and behind the W, the less the oil loses performance under the influence of the temperature. So a product with a viscosity of 5W50 better responds to temperature fluctuations than a 10W30. Until about 15 years ago, it didn't matter very much which oil you used in your car. Often it was a 15W40 or 10W40, and this oil lubricated excellent. Due to increasing attention for the environment, car manufacturers are also looking for possibilities to save fuel. One of those ways is to use a thinner oil, even though the primary purpose of oil is to lubricate the engine parts. The advantage of a thinner oil is that it generates less resistance so that the engine can run more efficiently. A logical consequence of this is that the engine uses less fuel and emits less CO2 emissions, something that the car manufacturers focus on. Over time, engine oil has become increasingly thinner, from 15W40 and 10W40 to 5W40 and 5W30. And these days you see products like 0W20, 0W12, and even 0W8, products thin like water. Trucks use thicker oils than cars, because thicker oils give more protection for more severe operations. Also, when the conditions are getting harder, it is wise to choose for a higher viscous product, such as driving through mountains, pulling a boat, dusty conditions, heavy loads, etc. Finding the optimal viscosity is finding a balance between engine protection and minimizing wear. You want the oil to be of lower viscosity to support efficiency and improve fuel economy by decreasing engine friction, but also give good protection at a cold start of the engine, since the thinner oils flows quicker through the whole engine than a thicker oil. But you want your oil as thick as possible to give protection in more severe operations. Therefore, you will see that trucks and other heavy-duty machinery are using normally thicker oils than cars, because thicker oils give more protection for more severe operations. Also, when the conditions are getting harder, it is wise to choose for a higher viscous product. The best viscosity depends on the type of machinery, on driving behavior, and external conditions. For industrial oils, you will see that these are not classified by ACEA, but by ISO, like ISO 46 or ISO 320. For industrial oils, you see in general monograde products, since these products don't face similar temperature fluctuations as in engines or gearboxes. Most people who don't understand much about lubricating oils only look at the viscosity grade of the oil, so they only search for a 15W40 or a 10W40 without understanding more of the specific characteristics of the oils. But there is much more to understand. For example, the type of base oil being used to produce this product. On our products, we will write about the type of base oil under the viscosity in the gold, silver, or bronze bar. A lubricant is composed of base oils and additives. In general, about 90% or more of the lubricant is base oil. So you will understand that base oil is an important component of the finished product. In general, we make a difference in mineral base oils and synthetic base oils. For both groups, the base material is overwhelmingly crude oil. The synthetic base oils are the base oils artificially modified or so-called synthesized. It means that these oils have gone through a chemical process to make them cleaner or stronger. The mineral base oils have gone through a less refined process. Within the synthetic oils, several classifications, or groups are made, depending on the processes the base materials have gone through, like PAO base oils and ester base oils. All with its own characteristics, making the products suitable for specific applications. Synthetic oils give all kinds of advantages compared to mineral oils. In principle, they give better protection than mineral oils. Synthetic oils give, for example, better protection against extreme temperatures, against oxidation and thermal breakdown, and they avoid sludge problems. And an important factor is that in general, the synthetic oils give longer protection than mineral oils. So mineral oils needs to be replaced faster than synthetic oils. But also, mineral oils can be preferred for certain applications. Mineral oils offer better seal compatibility, which make them more suitable for older vehicles. The main advantages of mineral-based oil is its cost-effectiveness. It is relatively inexpensive compared to other types of base oils, making it a popular choice in many industrial and automotive applications. Finally, there is also a group of base oils in between mineral and synthetic, which is often called semi-synthetic oils. Semi-synthetic base oils are a mixture of mineral oil and synthetic oil, which are engineered to have many of the benefits of full synthetic oil without the cost. At Rymax, we call these products synthetic blends, where the synthetics are called full synthetic. Now that we understand the importance of the base oil, it is also important to look at the additives. Although the additives make up for only a small part of the finished product, they play an essential role in composing a product. It is the additive that differentiates the lubricant types, such as engine oils, hydraulic oils, gear oils, and various fluids. The additives are mixed into the base oils to influence and boost their properties, minimize their unwanted features, and even add some new characteristics to the oils. Some examples of lubricant additives are rust inhibitors, antioxidants, and viscosity improvers. Additives are extremely pricey. Creating the perfect additives packages by choosing and combining different additive types is a very complex job done by additive companies. We, as Rymax, only use additives that are tested in the field by the OEMs. We use the additives of the so-called major four additive companies, which are Lubrizol, Oronite, Afton, and Infineum. The longevity of the additive package depends on the quality. The longer a lubricant is used, the less effective the additive package will become, because the additives degrade. Therefore, you always want to use the best additive packages and combine this with the best base oils to ensure maximum performance as long as possible. It is time to investigate the API classifications for lubricants, particularly their importance for heavy-duty machinery. The American Petroleum Institute, or API classification system, categorizes lubricants based on their intended application and performance characteristics. API classifications ensure quality assurance, compatibility, performance, warranty compliance, and serve as industry standards for lubricants. Quality assurance. API certifications indicate that the lubricant meets performance standards established by industry experts. Compatibility. API classifications help ensure compatibility between lubricants and specific engine components. Performance. API classifications indicate that the lubricant has been tested for wear protection, oxidation resistance, and thermal stability. Warranty compliance. Many manufacturers require API-certified lubricants to maintain warranty coverage. Industry standards. API classifications serve as a benchmark for the lubricant industry. Using API-certified lubricants is crucial for ensuring the optimal performance and longevity of heavy-duty machinery. But API doesn't just put its seal of approval on any oil, it rigorously tests and certifies oils to meet specific performance standards. For trucks, API offers different performance levels, each tailored to meet the demands of modern engines and operating conditions. Take API CK4, for example. It's designed for heavy-duty diesel engines and offers superior protection against wear, oxidation, and deposits. Or API FA4, a newer specification optimized for improved fuel efficiency and lower emissions. Or the API CI4 classification, a well-established performance category for heavy-duty diesel engine lubricants, and it remains popular even today for several reasons, like its performance, versatility, and cost-effectiveness. The API classifications help you choose the right oil for the right engine. If relevant, every Rymax product will show you the most important API spec. So, the next time you're in the market for engine oil, look for the API classification. It's the mark of quality that keeps your truck running strong mile after mile. Did you know that there's an organization ensuring the oils you use in your truck meet the highest standards? That organization is called ACEA, the European Automobile Manufacturers Association. They are responsible for setting standards and describing the specifications for engine oils used in trucks and other vehicles, originating from Europe, but accepted worldwide. ACEA's performance levels are like a roadmap for engine oil manufacturers and users. They tell you what oils need to do to meet the specific requirements of different engines and operating conditions. For trucks, ACEA offers several performance levels, each tailored to the needs of different engine types and applications. For heavy-duty diesel engines, you've got your E levels, like E2, E3, and E5. These are for older and less demanding diesel engines, while E4, E6, E7, and E9 are for requirements in more demanding conditions. The ACEA C levels are for engines equipped with after-treatment devices, such as DPF filters and catalytic converters. Finally, the ACEA A and B levels are for engines with a focus on fuel economy, emission control, and engine cleanliness. All these ACEA standards, or levels, ensure optimal performance, protection, and compliance with regulatory standards, whether your truck is tackling long-haul transportation or is equipped with advanced emission control systems. A very important factor to take into consideration when it comes to servicing and maintaining trucks, cars, and machines is the original equipment manufacturer, or OEM. These are the companies that design, build, and sell new trucks, and who are the suppliers for original parts and components. They often have their own specific requirements when it comes to lubricants. Let's take a closer look at some of the major OEMs in the trucking industry and their importance when it comes to lubricants. For example, we have Cummins, known for their diesel engine power solutions, like generators. They often specify lubricants that meet their own performance standards to ensure compatibility and optimal engine output of their generators. Next, we have Caterpillar, a major player in construction and mining equipment, and known as the brand with the yellow machines. They also have specific lubricant requirements for their engines and equipment used in trucks and heavy-duty machines to extend equipment lifetime and maximize performance, but also to maintain your right on factory guarantee. Then there's Volvo Group, which includes brands like Mack Trucks and a wide variety of heavy-duty equipment by Volvo itself, like trucks, excavators, bulldozers, and so on. Each brand and machine will have its own lubricant specifications to ensure compatibility and performance. Daimler Trucks is another important OEM, manufacturing brands like Mercedes-Benz, Freightliner, and Western Star. Other brands you can also think of are Scania, MAN Trucks, JCB, and Komatsu. Overall, OEMs play a crucial role in ensuring that lubricants used in the heavy-duty industry meet specific requirements for optimal performance, protection, and compatibility with modern engine technologies. Also, following their guidelines often is a condition to maintain your factory guarantee, which is an important economical reason when you own such expensive equipment. So, that was it. We have taken you through the most important basics of heavy-duty lubrication, from combustion and base oils to brake fluids, viscosity, and engine oils. You can watch this movie multiple times, or pause it if you want to make notes. Please let me know if you miss any information, and if you have any further questions, and don't hesitate to reach out to the Rymax product specialists at the headquarters. Thank you for watching. My name is Max from Rymax Lubricants. I hope to see you again very soon in the Rymax Academy.